The Soviet Union's 30-year obsession with Venus reveals a story of ambition, failure, and unexpected discovery. Between 1961 and 1984, Soviet Venera missions braved scorching heat, crushing pressure, and toxic clouds to study Earth's mysterious twin. Despite harsh conditions that melted lead, these probes did more than survive. They captured the first images from another planet's surface and sent back vital atmospheric data. But what did they really find? Was there life, or was it all a mistake? Today, we dive into the Soviet Venus missions and unravel their incredible legacy. The first attempts. The Soviet space program turned to Venus when Mars seemed too difficult to reach consistently. February 12, 1961 marked the launch of Venera 1, the first Soviet attempt to probe our neighboring planet. The spacecraft lost telemetry just 7 days after launch and drifted silently toward Venus, never transmitting data upon arrival. Venera 2, launched in November 1965, suffered a similar fate when its communication systems failed after leaving Earth orbit, but the Soviets refused to give up. Venera 3, launched on November 16, 1965, became the first human-made object to impact Venus on March 1, 1966, though it crashed without sending back any information. The breakthrough came with Venera 4 in June 1967, which successfully entered Venus's atmosphere and transmitted the first chemical analysis back to Earth. The probe revealed a dense hostile atmosphere composed of 90 to 95% carbon dioxide with crushing pressure and searing temperatures. Despite failing to reach the surface intact, Venera 4 proved that spacecraft could survive entry into another planet's atmosphere and paved the way for future missions to probe Venus's sulfuric acid clouds and scorching surface. First surface success, Venera 7, launched in August 1970, achieved what many thought impossible: the first successful soft landing on another planet's surface. The probe endured surface temperatures exceeding 465 degrees Celsius and atmospheric pressure 90 times greater than Earth's. For 23 precious minutes, Venera 7 transmitted data from Venus's hellish surface, providing the first direct measurements of conditions on another world. The mission was led by Soviet engineer Georgy Babakin, who had designed the spacecraft to be massively overbuilt to ensure survival. The probe's parachute partially failed during descent, causing it to topple over upon landing, but its robust construction allowed it to continue operating despite the mishap. This groundbreaking achievement proved that spacecraft could not only survive Venus's extreme environment, but also function long enough to send valuable scientific data back to Earth. The temperature and pressure readings confirmed what earlier atmospheric probes had suggested. Venus was a world of extremes where nothing resembling Earth life could possibly survive. Yet the successful landing opened the door for more ambitious missions that would soon reveal surprising discoveries about our planetary neighbor. First images from hell. October 1975 marked a historic breakthrough when Venera 9 and Venera 10 became the first spacecraft to successfully transmit images from another planet's surface. Venera 9 landed on October 22, 1975, followed by Venera 10 3 days later. The black and white photographs revealed a rocky, barren landscape covered in volcanic basalt formations and scattered angular boulders. The images contradicted earlier assumptions of a uniformly smooth, dust-covered surface, instead showing a world with surprising geological diversity. Each lander carried a suite of instruments designed by Soviet scientist Mikhail Marov that detected sulfur compounds and evidence of ongoing volcanic activity, suggesting Venus remained geologically active. The harsh atmosphere posed immense engineering challenges, but both probes exceeded expectations by operating for 53 minutes and 65 minutes respectively, far longer than their designed 30-minute lifespans. The images showed flat bedrock surfaces with loose regolith and revealed that despite the crushing atmosphere, substantial amounts of sunlight reached the surface. These missions fundamentally changed our understanding of Venus from a mysterious cloud-shrouded world to a dynamic volcanic planet with complex surface features that continue to intrigue planetary scientists today. Color and chemistry. The 1982 launches of Venera 13 and Venera 14 really represented the pinnacle of Soviet Venus exploration technology. For the very first time in history, color images were transmitted from another planet's surface, revealing this orange-brown terrain bathed in the eerie glow of Venus's thick atmosphere. Venera 13 operated for a record-breaking 127 minutes on March 1, 1982, while Venera 14 functioned for 57 minutes on March 5, 1982. These missions were overseen by Soviet planetary scientist Roald Sagdiv, who later became director of the Space Research Institute. Chemical analysis revealed surface compositions similar to Earth's basalt, but with some intriguing differences. Both landers detected evidence of layered rocks and possible erosion patterns that seemed impossible without liquid water. Yet Venus had been bone dry for billions of years. The X-ray fluorescent spectrometers found concentrations of potassium, uranium, and thorium in ratios similar to volcanic rocks on Earth, suggesting Venus had undergone planetary differentiation just like our own world. These discoveries sparked intense debates about Venus's geological past, and raised puzzling questions about how sedimentary-like features could form in such an arid, hostile environment. The missions really deepened the paradox of how Venus transformed from a potentially Earth-like world into a scorching wasteland. Balloons in the clouds. December 1984 brought the most ambitious Soviet Venus missions yet, Vega 1 and Vega 2, which combined atmospheric balloons with surface landers in an unprecedented dual approach. The balloon components, developed under the leadership of Soviet engineer Vyacheslav Lincoln, were designed to float at about 53 to 54 kilometers altitude in Venus's middle atmosphere for extended periods. Vega 1's balloon operated for 46 hours, while Vega 2's functioned for 60 hours, drifting approximately 11,600 kilometers and 11,100 kilometers respectively through Venus's turbulent skies. The balloons revealed Venus's atmospheric dynamics to be far more complex than simple greenhouse heating models had predicted. They detected violent wind turbulence, sudden downdrafts of 1 to 3 kilometers, and unexpected convection patterns that really challenged existing theories about planetary atmospheres. Meanwhile, the lander components analyzed surface composition using gamma-ray spectrometers, and discovered that Venus's lower cloud layers likely contained phosphoric acid, rather than just sulfuric acid. The atmospheric data showed that Venus's climate system involved intricate interactions between surface heating, cloud formation, and global wind patterns. These Vega missions pushed the frontiers of planetary meteorology and atmospheric chemistry, providing insights that continue to influence climate models for both Venus and Earth today. The life controversy. In 2012, Russian scientist Leonid Sanfomality from the Space Research Institute made headlines by claiming he had discovered signs of life in 30-year-old photographs from Venera 13. Sanfomality analyzed the images using modern digital enhancement techniques and identified several objects that appeared to move between photographs taken just minutes apart. He suggested these moving objects, which he dubbed Disk, Black Flap, and Scorpion, might represent primitive life forms adapted to Venus's extreme environment. The scientific community, though, reacted with intense skepticism. NASA astrobiologist David Grinspoon and other planetary scientists quickly pointed out that the apparent movement could easily be explained by image processing artifacts, shifting debris, or maybe even mechanical parts from the lander itself falling into view. The surface temperature of 462 degrees Celsius and crushing atmospheric pressure make it virtually impossible for any known form of life to survive. Some Russian Venera probes had indeed detected particles in Venus's lower atmosphere about 1 micron in length, roughly the size of bacteria, but these were most likely dust particles or atmospheric aerosols rather than biological organisms. While the controversy generated significant media attention, the scientific consensus remains that Venus's surface conditions are far too extreme to support any form of life as we understand it. Scientific legacy. The Soviet Venera program, achieved an unprecedented string of planetary exploration firsts that fundamentally transformed our understanding of Venus. Venera 3 became the first human-made object to reach another planet's surface. Venera 4 performed the first atmospheric analysis of another world. Venera 7 achieved the first successful planetary soft landing, and Venera 9 transmitted the first images from another planet's surface. Between 1961 and 1984, the Soviets launched 28 Venus missions, with 13 successfully entering the planet's atmosphere and 10 reaching the surface. The program's success rate honestly improved dramatically over time, with later missions like Venera 13 and the Vega probes operating far beyond their design specifications. The data collected revealed Venus as a world of extremes: surface temperatures hot enough to melt lead, atmospheric pressure equivalent to being 900 meters underwater on Earth, and clouds of concentrated sulfuric acid. These discoveries showed that despite Venus's similar size and mass to Earth, the two planets had evolved along completely different paths. The Venera missions demonstrated that robotic exploration could achieve remarkable scientific discoveries at a fraction of the cost of human missions, establishing templates for planetary exploration that continue to influence mission design today. The Soviet achievement to this day remains unmatched. No other nation has successfully landed on Venus since 1984. The search for ancient oceans. Recent analysis of Venera and Vega data has, really renewed scientific interest in Venus's mysterious past. The atmospheric measurements revealed deuterium to hydrogen ratios, suggesting Venus once possessed substantial water oceans that gradually escaped to space over billions of years. Venera 12 detected lightning activity in 1978, indicating ongoing atmospheric dynamics that might preserve clues about the planet's watery past. The surface composition data from multiple landers showed evidence of granite-like rocks that on Earth typically form through water-mediated processes, raising some pretty intriguing questions about Venus's geological history. Soviet atmospheric chemist Mikhail Zolotov later proposed that Venus might have remained habitable for up to 2 billion years after formation, potentially long enough for life to evolve before the runaway greenhouse effect took hold. The phosphine detected in Venus's upper atmosphere by Earth-based telescopes in 2020 has reignited debates about possible microbial life surviving in the planet's clouds, though this remains highly speculative. While the Venera missions found no direct evidence of life, their comprehensive atmospheric and surface data continue providing crucial insights into planetary evolution and the conditions necessary for life to emerge and survive in extreme environments. Engineering marvels. The engineering challenges overcome by Venera spacecraft represented, honestly, some of the most impressive technological achievements of the Cold War space race. Each lander had to survive a journey of over 100 million kilometers through space, then endure entry into an atmosphere 90 times denser than Earth's, all while maintaining structural integrity under crushing pressure and corrosive conditions. Soviet engineer Georgy Babakin's design team developed specialized materials and cooling systems that could function in temperatures exceeding 450 degrees Celsius. The landers used titanium pressure vessels and thermal insulation systems that pre-cooled the internal electronics before landing. Venera 13 and 14 employed spring-loaded mechanisms to eject protective lens caps and deploy soil sampling arms in the hostile environment. The Vega balloons represented even greater engineering complexity, requiring altitude-controlled floating platforms that could survive sulfuric acid clouds while maintaining radio contact across interplanetary distances. Communication systems had to penetrate Venus's dense atmosphere and transmit across millions of kilometers back to Earth, using only limited battery power. The success of these missions demonstrated Soviet technological superiority in planetary exploration during the 1970s and 80s, achieving engineering feats that remain impressive by today's standards and inspiring current Venus mission concepts being developed by NASA and other space agencies. Modern revelations. Contemporary analysis of Venera data using modern computational techniques, continues revealing new insights about Venus's evolution and its potential for past habitability. Computer models based on atmospheric measurements from Venera 11, 12, and the Vega probes suggest Venus might have maintained liquid water oceans until as recently as 715 million years ago, much later than previously thought. The surface composition data collected by multiple landers indicates Venus underwent extensive volcanic resurfacing within the past 500 million years, potentially erasing evidence of earlier, more temperate conditions. Recent studies of the phosphine signatures detected in Venus's atmosphere have prompted renewed examination of Venera atmospheric data, though no definitive biosignatures have been identified. NASA's planned Veritas and Da Vinci Plus missions will build directly on Soviet discoveries, using advanced spectrometers and imaging systems to investigate the tantalizing clues left by the Venera program. The Soviet Venus missions established that, while the planet's surface remains utterly hostile to life as we know it, its atmospheric chemistry and geological history contain important secrets about planetary evolution. These missions proved that systematic robotic exploration could unlock the mysteries of even the most forbidding worlds, setting the stage for future discoveries that may finally answer whether Venus ever harbored life. The Soviet Venera and Vega missions transformed our understanding of Venus from a mysterious, shrouded world to a dynamic volcanic planet with a complex atmospheric system. They achieved humanity's first images and chemical analysis from another planet's surface, establishing crucial foundations for all subsequent planetary exploration. Though no definitive signs of life were discovered, these pioneering missions revealed a world with a rich geological history and atmospheric complexity that continues to intrigue scientists today. Subscribe to Stellar Tech for more deep dives into space exploration's greatest achievements, where scientific truth meets human curiosity and, discovery awaits.